So hi, it's Amma here and I'm explaining you the Lab5 which is of a counter. So as we know, every code in which we have like our entity as well as architecture. So in this entity we have mentioned our max value as 2 raised to 16, which sums up to 65,535. So it gets to that, right? And our simulation is true. It is true for for simulation where like we need to do simulation and synthesis. So for synthesis it should be false, and for that count it's like log to the base 2 of 65536, it's 16 down to 15 down to 0. And we have also like clock and reset, so we could define it as we are not giving any input here. And after that we have also mentioned the depth here, so it again sums to 16, so my count reg is 16 down to 15 down to 0. And my signal counter is like 25, it's like 26 down to 0, 25 down to 0. Similarly my max count is like, which we have calculated it by dividing the clock frequency, which comes up to 10 raised to 6, and my max count reg is 65536, which is equal to 2 raised to 16. So what exactly this code does is like at every process, like the sensitivity list is filled with the clock. Yeah, and this vector is been we assign into it to the count. So we have performing the conversion from unsigned to std logic. And for here it's like for every rising edge, if my reset is 1 or my counter goes to max counter 65535, then it counter again rolls back to the 0, or else it will just increment. So it's a normal logic which we have designed. And then for synthesis as well as simulation, so for this part uh, we have mentioned it as for our simulation. For the simulation purpose, my simulation should be true, so we have mentioned it true above. And again it's the same, like if my reset is 1 of, if my count reg goes to max, it would turn out again to the 0, like, and else it will go. So now let's and we have also have a test bench. So in this test bench what they have defined it as, for max value is defined as 2 raised to 30, and again my count is gone to 15 down to 0, and again clock and reset. It is based on our a design user test, and my max val is 10. So basically my counter will maximum go to like 10, 0 to 10, and then again it will roll back to 0. So again we have again mentioned it, like be given initial values to it, and then we have created a processes. So basically for simulation after a certain amount of time, so we are basically toggling the clock for after a certain period of time. And again we have also mentioned a generic map, like which sums to maximum value. So it is used like to instantiate like a different type of counter, like hexadecimal and all, we could define it as in this. Yeah, so this is it. And now let's go to our model sim. So this I have executed it without any errors. So now let's see our count is. So considering the fact that see here, first of all, as we know, my first it's to 0, and then for the first clock edge, first edge of the clock, you can say, so you can say it's 0, then the value gets 1, then 2, 3, 4, 5, 6, 7, 8, 9, and then it's A. So it roll back to A again. So yeah, so this is like what we have seen in the test bench. After the value of 10, it again reset back to 0. So this is something about the model simulation. And we could see this, our count goes on increasing every now and then, you can see here. So my 5, 6, 7, 8, so this value goes on increasing again. So yeah, so this is the first part, and now let's move on to the second part. So after that we have seen like here my counter goes on increasing hex value. So it will go to like again to this max value, and then it will again reset to 0. And this is our BCD counter, which is basic, like, so it goes to 10. And so yeah, now let's move on to our second part, that is our Vivado part. So for that we have like this synthesis file. So what exactly we know, we have set the clock which works as like 100 megahertz. So that's our one of the thing. And as we know, we don't require any inputs, but we require LEDs to have a validation key how exactly my outputs are going on the FPGA board. So I have like 2 raised to 6, it's like 16, so 16 bits, so 0 to 15 I have defined it. And then I have gone down to setting of like we require, as we have already set the clock there. So for me the next thing is like to set it the reset. So again I have set the reset here, my BTNC pin on the FPGA board. And so after that, now after including this DUT and this, so now our task is to like check on the FPGA board what exactly is happening. So let's move on to it. So yeah, so as we see, this is our FPGA board. And as we see this first 4 bits which are quite stable because it's like 100 megahertz, so it's like it's a wink of a naked eye. So and after that we see it's my count is been increasing here, so it's just shifting out here and here and here and there. So we see my count is increasing here. And after that we see if I press the reset, it again goes to 0. So again it starts counting from the start. So we see this bit was not set here, and this has been moving each time, like it's the counter has been going like 2 raised to close to the value of 2 raised to 16. So yeah, this is quite stable for a bit, but we can see it's been logging here. And data has been it's been counting its values. So it's basically like the pattern has been generating 1 0 0 0 0, and then it's like, so every time we see it's been populated, then after completion of this it again goes back to 0. And so it's after max value we have seen, after blinking of the certain lights, it again like this my bits gets it doesn't blink, like, so at that time it is reach my max count. So that's one of the reason for it. And the next thing is like we can see here, see it's been logging my bits 1 1 1, then 0, then this pattern, then we can see here, see again it goes to my max count has been reached, and then this. So and again confirming this, when I press the reset, which is my BTNC, so it again goes back to like something which from the start. So it's been triggering every clock edge for after a certain time, and then it's been counting. So yeah, so that's it from my side. So I've explained to you the like model sim and then the Vivado part as well on the FPGA board. So this sums up my Lab5. So basically these two things were were the requirement to show. And yeah, thank you.